explain to you about the reactive ion etching process. After lithography, the wafers will proceed to the next process, which is RIE. RIE is a process of transferring microplating from photoresist onto the dielectric film on silicon wafer surface. This means that areas that were left uncovered by the photomask will be removed. RIE is repeated every time there is a process involving lithography or masking. What is the difference between wet etching and dry etching? Wet etching uses wet chemical solution and it has high selectivity and etching rate. It is an isotropic process, which means that the reaction is uniform in all directions and the etching chemicals may remove the substrate material that we do not intend to etch. Wet etching costs higher as the etching chemicals need to be constantly replaced to maintain the etching rate, and since its byproduct is chemical, the disposal cost is also high. Dry etching uses plasma or high energy ions to remove the targeted material, and it is an anisotropic reaction where the process only occurs exclusively in one direction and the process is easier to control. This is significant as we do not want to remove materials under the photomask, and the critical dimension loss will be almost 0 to none. This process also costs less as its byproduct is in gas form, thus lower handling and disposing cost. However, dry etching has a relatively low selectivity. Disadvantages of wet etching are complexity to control critical feature dimension and the degree of over-etching, decrease in etch rate as reagent solutions are consumed over time, difficulty to handle not only because it uses pure hazardous chemical, but the film it produces is also toxic. RIE is a process assisted by plasma. What is plasma? Plasma is a partially ionized gas consisting of positive and negative charges, electrons, as well as some other numbers of non-ionized gas particles. How does RIE work? First, the process chamber is vacuumed and filled with gas. Plasma is initiated by applying radio frequency power at 13.56 MHz to the powered electrode, which is the cathode, and the anode or the vacuum vessel is grounded. The oscillating electric field, which sustains the plasma between the platen and the showerhead, ionizes the gas molecules and creates the plasma. The applied energy accelerates electrons, increasing its kinetic energy. The electrons accelerate up and down, striking both chamber upper wall and the wafer, while colliding with the neutral gas molecules. This forms more ions and more electrons. Electrons deposited on the wafer platter cause the platter to build up negative charge, which leads to an increase of flash negative voltage. The plasma itself develops a slightly positive charge due to higher concentration of positive ions compared to free electrons. Because of the large voltage difference, the positive ions tend to drift towards the wafer platter and etch the wafer as they collide. Etch process input variables are pressure, temperature, power, type of gas etchants, and others. The output process parameters are the etch rate and non-uniformity, selectivity, critical dimension, and CD bias. Etch rate is defined as the speed at which the target film is removed, calculated using the thickness of film removed over time. Uniformity is described as a comparison of etch rates between different points on the same wafer or same points on different wafer. There are three types of uniformity comparisons, which are within a wafer, wafer to wafer, and batch to batch. Selectivity is a ratio of etch rates between etch target material to the etch rate of underlying film or masking material. It indicates how much underlying film and the mask are etched as the target material is etched. Higher selectivity means less underlying film is etched away during over-etching time. Over-etching is another term in etch output parameters. Extra etch time is required to clear etch residues at the endpoint due to etch rate non-uniformity and the underlying layer topography. Etch process has three main steps. First is the stabilization step. In this step, there is only gas flow with no RF power. This step is to stabilize the gas flow and the pressure setting. Next is the main etch step, where the gas and RF power are both turned on. In this step, all the mechanisms explained before occur. Main etch time is the desired film thickness to remove over the etch rate. The last step is over etch step, which is the continuation of the etch process for a percentage of the main etch time. Presence of residue, which requires over etching, are due to several reasons such as non-uniformity in the deposited film and the etch itself. Advantages of using RIE are etch directionality. The relatively unreactive gases can be made highly reactive at room temperature. It is a cleaner process. It can be controlled with greater precision and it consumes less materials. Etch applications in CMOS fabrications are active etch, poly etch, spacer etch, contact etch, metal etch, wire etch, and pad etch. Next, we will proceed to the diffusion process, which will be explained further by my friend. That is all from me. Thank you.